All right. Okay. All right. So let's get started. Presentation. Our second last presentation. Presentation number 7. Are you guys all ready? So today what we're going to do, we're going to go through the presentation. Then I'm going to show you how your 3D should look like. We'll talk about the 3D project. And then I'll open up Teams for any questions. And then you guys can all come in. So William will be presenting. Okay, so I'll give William presentation rights. So everybody here is here from your group, William?
Yeah, we're all here.
Excellent, thank you. So I just made you a presenter. Excuse me, you're going to give me a few minutes, so I'm going to go through the attendance, like every time, and then we'll get started. Okay, so you guys are all ready? Hello, Sanjeev. Hello. Okay, excuse me. Okay, Michael Abunasar. Not here. Okay, Arifin, you're here. Heard you making comments about my nice weather. Hassan Aziz, I think you're here. Yes, thank you. Sanjeev, you're here. Sebastian, you're here because you're presenting. Okay. Jerwin. Jerwin? Not here. Yeah, Sanjeev just left, so he's not here. Okay, Harshal. Thank you. Dewu. Thank you. William, you're here because you're presenting. Trong, Hayden, and Shri. Okay. Raymond. Thank you. Bill Gunn, you're here. I already saw. Zero. Q. Samuel. Thank you. Gabriel. Not here. James. Oh, sorry, Brian. I don't know why. It's because the way it's the closest name to me. So Brian, you're here. I saw. Thee. Thank you. Ifani. Or EJ. Yeah. Thank all. Hong Wei. Thank you. Saw that. You're here. I saw you making a smart remark about my many assignments. Ren. Michael McDowell. Not here. Hong Lin. Thank you. Valerie. Thank you. Asya. Thank you. Hassan Safwan. Nope. Okay. Sorry, I missed Trong. Trong, you're here, right? Thank you. I missed you. I don't know why. Hi. Thank you. Before I even said, Renique. And Carla. Not here. Shubham. Not here. James. Not here. Prem. Thank you. Claudia. James, you're here? Okay, thank you. Claudia, thank you. Kiefer. Refunk. Thank you. Hayden, I'm assuming you're here. Sir, thank you. Oh, Kiefer's here. Thank you. Okay, and Lushui, I'm assuming you're also here. Excellent. Thank you. All right. So, it's your time, guys. Have fun with it. Enjoy. Good luck.
Hi everyone. We're group 7, and today we're talking
Hold on,
about.
sorry. Well, before we start,
Sorry.
1 second, guys. 1 second. I'm very sorry. I haven't muted myself. I apologize. But Hassan, can we discuss this in the next part? You can just message me again after. I'm not really sure what we're talking about here, but let's stay with group number 7 for now. Okay. Again, sorry about that, guys. Good luck. I'm gonna mute myself now. Go ahead.
Okay. So we're group 7. Today we're going to talk about a rapid bridge replacement. As you may know, the transportation system is very important for everyday commute and also for transportation of commerce and goods. One of the most important components of transportation systems is bridge. So today we're going to talk about it, and I'm going to give Sebastian to introduce to you guys what is rapid bridge system.
Hello everyone, my name is Sebastian. So as my team member Andrew mentioned before, the importance of transportation and having good quality of bridges, we'll give a good introduction about this new topic of rapid bridge replacement. So according to the American Society of Civil Engineers, almost 40% of the nation's bridges are around 50 years old, and 9.1% of bridges have structural deficiencies. As you may know, this is one of the big challenges that engineers in America and the rest of the world are facing right now, as bridges reconstruction takes several years and also they're very expensive. As an alternative for the traditional bridge construction, we will introduce you to a new construction method called rapid bridge replacement, mostly known as accelerated bridge construction. So let's begin with the issue. What's the problem and what are we trying to improve throughout this presentation? So over time, as you may know, bridges start to have structural deficiencies, as you may see in downtown Toronto, around GTA, as well as they start to deteriorate physically. Even though reconstruction of a bridge takes a lot of time, creating several delays and transportation impacts. This is one of the main reasons rapid bridge replacement will mitigate these issues and improve the effectiveness of a bridge construction project. In addition, there will also be lower construction costs, reduced environmental impacts, and improved bridge quality and longevity. So I will give you guys a really specific definition of what rapid bridge replacement is to give you a better understanding. So rapid bridge replacement means constructing bridge components off-site and then transporting them to the work site for installation. This method uses innovative planning, design, materials, and construction procedures in a safe and cost-effective manner. So now that we have a very clear understanding of rapid bridge replacement, some of its benefit, we will get deeper into system design.
So rapid bridge replacement is made possible through the use of prefab bridge elements and systems, or PBES. Structural components of a bridge, entire sections, or entire beam bridges are built off-site or near-site. They are installed into place using SPMT. These components reduce construction time by reducing or eliminating steps from traditional bridge building, such as formwork and shoring. Next slide. In rapid bridge replacement, all structural elements can be pre-assembled at dedicated facilities and then transported to an assembly location near the site. Prefabricated components include beams, piers, footings, and much more. A common practice in rapid bridge replacement is the use of prefabricated decks, which allow concrete to be poured off-site prior to installation or poured on-site. Next slide. Thank you. A PBES system is where the entire system structure is pre-built and installed as a whole at the site. This method allows existing concrete piers to be reused, saving considerable time, money, and other tangible resources. Self-propelled modular transporters, or SPMTs, are the machines that enable rapid bridge replacement. The SPMT, are we on the same slide? Sorry, I think it's the next slide. I'm on the slide for SPMT. Oh, perfect, thank you. Self-propelled modular transporters, or SPMTs, are the machines that enable rapid bridge replacement. The SPMT consists of a flatbed trailer with dozens of tires underneath, with tires either motorized or programmed for braking and turning. SPMTs are widely used in both shipbuilding and large-scale construction projects, such as bridge building. Much like work trucks and heavy equipment, SPMTs are specified for each application and therefore vary in dimension, capability, and capacity. Next. SPMTs allow bridges to be replaced in relatively short periods of time, as entire sections of a bridge are lifted into place with the SPMT on a single planned weekend where traffic is minimal. Formwork, shoring, and scaffolding labor is significantly reduced. The use of SPMT to replace aging bridges has become widespread due to its efficiency. The vastly reduced construction time also translates to much lower pollution levels and millions of dollars saved in labor expense. Thank you.
So there are 7 major steps to implement rapid bridge designs. First, the worker needs to ensure that the traffic is redirected off the site for safety of workers. Then demolition happens when old bridges pieces are burned out of the site. Then the site takes place. The most economical and the quickest solution is chosen for the project. The contract is signed after the design is verified. After that, prefabricated bridge deck is mobilized using self-propelled modular transporters. All deck pieces are plugged into the existing bridge decks, and inspections comes after the construction is done. To meet the schedule requirements, the fabricator had to reschedule all the work and to implement the 24-hour work schedule for replacement projects. To coordinate with the steel fabricator schedule, the managers changed his normal operation procedures and conducted agency-required inspections at the steel plant fabrication shop. As per the design objective, there are 3 major objectives during the design stage for rapid bridge replacement. One objective is to make sure that a bridge constructions can be conducted quickly based on the design drawings and specifications. Another is to expedite the design process itself. The damaged bridge can be replaced using either identical structure or a new structure. The decision maker has to consider which alternatives can best deliver quick and economical reconstruction of the bridge. The final objective will be to minimize the impact to the traveling public. Next slide, please. So as for the rapid bridge techniques, I'll introduce the casting techniques that create the bridge decks for rapid bridge replacements, which are inverset and concrete maturities. These techniques help create solid, well-structured concrete deck that withstand cold weather and are corrosive resistant, which are suitable for Canadians' weather condition too. They offer a quick way to check the concrete strength. For Inverset, this is the bridge system developed by Inverset combines the advantages of steels, concrete, and unique manufacturing process. An upside-down deck casting techniques result in a pre-compressed concrete deck that can result in 30% savings in steel weight. Because the deck is casted upside down, the densest concrete becomes the wearing surface, unlike side-cast decks where the surface concrete is likely to be the most porous. This helps eliminate deck crackings for a more durable deck, which is highly resistant to abrasion traffic, freeze-thaw cycle, and corrosive solutions. Because the Inverset units were produced inside the fabrication plant, winter weather has no impact on the production and delivery of the units. It was critical to the reconstruction of the bridge during the cold seasons like in Canadian weather. Each inverset unit was fabricated to cover the entire span, but provided only a portion of a bridge width. The units were installed side by side to complete the bridge lateral dimension. Next slide, please. So the benefits will be highly adaptable to Canadian weather, especially if the construction is taking place during the winter, where we only have a few days of warm weather. Obviously, it's easy to deliver because the fabrication process takes place indoor. And another benefit would be eliminate deck cracking as much as possible because of the invert structure. So as for concrete maturities, in addition to using new structural members, design engineers allow contractors to use the concrete maturity method to expedite bridge reconstruction. Concrete maturity is a method for determining real-time in-place concrete strength using internal temperature. As soon as the concrete reaches 100% design strength and has a minimum of 3 days of curing, concrete forms were permitted to be removed. Moments loading were allowed to be applied in the structure. Next slide, please. And so these are the Ontario application. So these are the rapid bridge design project that are implemented in Ontario. The first one that I would like to introduce is the Highway 400 Bridge crossing Finch West. So this project is the project involving a Highway 400 to the northwest of the cities. It saw remarkable progress of replacing an entire major span in Toronto. And the picture below is the satellite view of Highway 400 crossing Finch Avenue, which has 4 lanes on it, and the project replaced the steel deck, the concrete deck there. So the rapid bridge replacement technique reduces the timeline for disrupting traffic for many years, which is for weekends and overnight in this project. This process also allows most of the new bridge construction to take place beside the highway and not on the road, impacting traffic less, allows to building the new bridge more quickly, since as they're not operating in the live traffic areas, makes the new bridge available in less time than traditional bridge rehabilitation methods, and requires necessary closure of Highway 400 only overnight or specific weekends. This project is, so the crew worked on one side of the bridge at a time over 2 weekends to replace old components with new prefabricated panels. And so the rapid bridge replacement actually reduced the traffic interruption a bit. Next slide, please. The next project would be the Highway 417 rapid bridge replacement. So the purpose of this project is to replace Kent Street bridges with 2 new bridges. The project is located to the east side of Percy Street, which is also under the rapid bridge replacement plan issued by the Ministry of Transportation. As you can see on the map, the Kent Street strand is located to the south of Ottawa River, to the east of Chinatown and Centertown River, and to the west of Rideau River. On the right hand, you can see the bridge structure and real-life geometry of Highway 417 from Kent Street Ram. So you see in the picture on the right side, that's the satellite view of Highway 417 of Kent Street Ram. Is a very new and big highway, which also have the bridge crossing over. So the project involves the preparation of temporary closed construction staging areas for the bridge replacement activities, including construction equipment access roads, new bridge components, and demolition of existing bridge. Construction operation on City Street to provide the rapid replacement equipment with access from construction staging area to the bridge sides. And the project only lasts 1 week, from October 21st, 2015 to October 25th, 2015, which really reduce the time compared to rehabilitation. And next slide, please. And this is the video of how it's constructed. Okay, so that's for the time lapse of Kent Street Rapid Bridge replacement. And the last project I'd like to introduce is the Island Park Drive. So the project's limits are along Highway 417, known locally as Ottawa Queensway, from Maitland Avenues to Island Park Drive, where widening of the freeway is taking place to 4 lanes in each directions, as you can see on the map. Figure 5. Next slide, please. Yeah. So over there is the bridge crossing on Island Park Drive. This was also one of the satellite views, just to give you a clearer perspective of what is there. Next slide, please. So the project is completed by Ontario Ministry of Transportation from August 11th, 2007 to August 25th, 2007. And the purpose of this project is to replace 3 twin bridges on Highway 417. So the total cost for this project is estimated to be $2.4 million. Rapid Live's operation is completed within 15-hour works. So the twin structure that were built in 1961 and span a local road underneath. The bridge have a single span slab-on steel girder bridge superstructure and have a very high screw angle of 50 degrees. The span length is 25 meters with the width of each of the structures approximately 18 meters. The abutment is the conventional concrete walls on spread footings with a height of approximately 6 meters above ground. The Ontario Ministry of Transportation used the rapid replacement techniques for the first time in Canada to remove and replace 2 bridges. So the removal and replacement of bridges required the complete closure of Highway 417. The ultimate context-sensitive designs converted the bridges to semi-integral abutments, used adjustable bridge bearings, and increased worker safety by allowing constructions to be performed in a safe environment without exposure to traffic. The design included a full risk assessment and required coordinated team effort. Experts from the Ministry, City of Ottawa, the contractor, and representative of heavy lift technology and transporter worked together to ensure project success with minimal impact on the environment. So the next slide will show like the environmental impacts using of the rapid bridge replacement of Island Park Drive. So as you can see on the chart, the amount of emissions is reduced significantly, including the amount of HC, CO, and NO. So as you can see in HC, it's produced from 27,775 kilograms to approximately 800 kilograms, which is more than a lot of times. And then for CO, follows the same patterns from 300,093 356 kilograms to just approximately 11,000 kilograms, which is 30 times smaller than the original one. And then finally for NO, it's reduced from 25,465 kilograms to 700 and 330, which also follow the same pattern. So you can see how much the environment is saved if we use this rapid bridge replacement method. And Canada is also an environmentally friendly country, and it's very reasonable if we implement this rapid bridge replacement design and for the maintenance. So this is the summary of the environmental impact. So it's definitely reduced a lot of emissions. So if we reduce the amount of traffic delay, then there will be no car stall. And if there's no car stall, then there won't be any extra emissions for stalling. And it's proven that moving traffic produced around 10% to 7 to 12% less emissions than the idle traffic. Because when the engines stay idle, then the amount of gas we put on the pedal would be more, then there'd be a lot more pollution if we stop the traffic. So that's it for the project and environmental impact. I'll give it to William.
Hi everyone. So I'll be talking about the traffic accommodations that are typically employed for rapid bridge construction, as well as the advantages that come with rapid bridge construction later on. So first, with the traffic accommodations, and if the traffic accommodations required for a rapid bridge replacement are no different than those employed for any type of construction project that would disrupt traffic conditions. An effective traffic accommodation strategy, or TAS, must be able to address the following. 1, accommodate all the required activities for rapid bridge replacement. 2, provide protection for workers and equipment within the work site, and enable traffic to pass safely with minimum inconvenience through or around the work zone. The complexity of TAS, sorry, I just got to switch the slide. The complexity of TAS varies according to the nature of the work that needs to be accommodated, as well as the duration of work, highway geometry, traffic volume, and other inherent site conditions. In all cases, the minimum required lane width must be maintained at all times. The following accommodations are most commonly used for rapid bridge replacements. First, detours. A detour must be provided in the event of a road closure. Examples of commonly used detours include local roads, median crossovers, and counterflow with an information guide. Signs communicating this. 2, protecting pedestrians and cyclists typically involves providing a safe passage through or around the work zone. It may also include signage alerting pedestrians and cyclists of a sidewalk or road closure and the option of an alternative route. 3, TCDs or traffic control devices. These are portable devices that are pre-programmed to direct traffic flow with pre-timed or actuated design. The actuated design is meant to 1, advise road users of an imminent work zone, 2, divert traffic from its normal path when necessary, and advise road users when it is safe to resume normal speed. The second purpose of a TCD is to provide needed protection for both workers and road users. Lastly, TCDs must be able to provide adequate transitions for the speed and traffic volume passing through the work zone. 4th, temporary warning signs. Warning signs advising road users of the work ahead. Examples include the following types of signs: road work, flag person, survey crew, uneven mat, and begin detour 300 meters ahead. Lane closures and speed reductions typically applies for multi-lane provincial highways with speed reductions taking place along the transition into the work zone. The advantages of rapid bridge replacement are as follows. First, time savings. The ability to quickly complete critical infrastructure upgrades to minimize traffic delays and subsequently keep people and goods moving across key corridors that are important to the economy. 2 examples, as mentioned by Trong already, are the bridge structure along Highway 401 that was replaced in 53 hours over a weekend, and the bridge structure, actually the second one he didn't mention, which is the one I'm about to talk about, Highway 400 for the Finch LRT project that was built over 2 weekends, versus say a 2-year replacement period, which would have been the more conventional approach. 2, cost savings. Labor costs are greatly reduced due to the minimal time spent on site. The rapid overpass replacement of Highway 417 Island Park Drive in Ottawa, Ontario, resulted in a $2 million savings than the traditional design bid-build approach. 3rd, parts are fabricated in a shop, which means that it results in a higher quality build that would otherwise be difficult to achieve due to the variability in site conditions. 4th, reduction in CO2 emissions, substantial reduction in harmful emissions due to reduced site work. CO2 emissions were estimated to have been reduced from 400,000 kilograms to 11,000 kilograms for Highway 417 Island Park Drive in Ottawa, Ontario. And lastly, the societal benefits. It expands the capabilities to keep aging infrastructure in a state of good repair. Lastly, we just have a time-lapse video of a rapid bridge replacement for Highway 417 in Ottawa, Ontario. This concludes my part of the presentation. I will pass it over to Lushree, who's going to talk about the limitations of rapid bridge replacement.
Hi, this is Lushree, and this is a limitation. Rapid bridge replacement is a complex operation involving many aspects. It requires all parties to make technical and management decisions at different stages in a very short time. Poor communication and coordination can lead to cost overruns and inaccurate construction schedule forecasts. The construction process needs to be very smooth, otherwise it will have a great impact on people's daily travel. At the same time, there are strict requirements on bridge to be constructed and the construction process, for example, is not suitable for projects with excessively high pier. The length of steel beams is limited. The span must not be too large. The requirements for foundation are high, and the construction of beam is avoided during jacking. Eccentric compression and excessive deformation of the stand occur. And next slide, please. For the cost, according to the completed Highway 400 bridge crossing Finch Avenue West project, rapid bridge replacement will cost about $100 million per kilometer, including the price of materials such as steel, concrete, gravel, and asphalt. There are also the price of large engineering equipment such as tower crane and jack cranes. At the same time, it also requires a lot of labor costs, such as engineers involved in design stages and field construction personnel. Since rapid bridge replacement will seriously affect traffic during the construction process, many projects will have an incentive for completing the project on time during the construction process. The estimated costs vary and will be determined on case-by-case basis. Thank you.
So that concludes our presentation. Thank you very much for listening. So here are all of the references. Thank you so much for listening.
Thank you, guys. Thank you very much. Okay, let's get started with any questions for this really cool invention. Any questions? I don't even know if they are here. I'm not. Can you guys hear me? Okay, so does anybody have any questions for bridge replacement? It's pretty straightforward, but okay, I do have one question. Did you guys come across any example of the inverse bridge? You know, the one that who was talking? I think it was Strong.
Yeah, that was me.
Yep. Yeah. Did you come across any of those examples?
Yes. So for the Island Park Drive, that was actually a project that used the inverse that.
Oh, is it?
Yeah. So it was mentioned in one of the reports from Ministry of Transportation. Yeah. So yeah.
That one was done that way, but that's pretty cool. Okay, sounds good. Thank you. Hassan has a question. Is this way popular in Canada because it's expensive?
So this kind of technique is very new to Canada, but I would say it'll be very cost effective, especially in winter, because during the winter, say if the worker only have 5 days to work and there are only 3 days of snow, then they only have like 2 days to work. And during that 2 warm day, we need those techniques that actually accelerate the speed of rehabilitation.
Okay.
Yeah.
Yes, that's true. It is new. Where was this? The rapid bridge replacement really did. Where did it start?
So actually, one of the projects we introduced, the Island Park Drive, was first introduced for the rapid bridge replacement in 2007 in Canada.
In Canada, but before that.
Before that, they did some research at the beginning of 2000, but only until 2007, they actually implemented some project in Ottawa, which is one of the first projects that what we found.
That's in Canada, though, right?
Yeah, that's in Canada.
But outside of Canada, where did it actually start? Is it in the U.S.?
Yeah, it's in the U.S.
I can answer that question. I think the University of Florida.
Okay.
National University started the research, and they created a group of engineers and students on the investigation about a accelerated bridge replacement. So, like in the States, they mostly use that term ABC as accelerated bridge construction.
Sounds good. Thank you. Samuel had a question. Is it always recommended to use RBR for all bridge-related projects?
So for the bridge that is constructed with loose frame, we can use the rapid bridge replacement. But with the stiff frame, since we cannot put all of the component decks out, because according to the principle of rapid bridge replacement, they're cut into pieces and then they're plugged in together, but with the existing decks, right? And if they're built within the stiff frame, it's very hard to remove them. So instead, they just do rehabilitation for that. But a majority of the new highways, so like Highway 17, they have built with a newer method with a more modern frame. So we can use rapid bridge replacement for new projects.
What is what's the largest size they can create? Like, I know you're saying pieces, but what's the biggest piece that they can create, out in for rapid bridge replacement? Did you guys come across anything we're talking about sizing?
I believe the largest PI I've seen, like during research or real life, is only equal to the width of like 8 lanes. So they can, if they go beyond that, is like, so they have to prefabricate all of the decks and the prefabrication plan. So in order to transport them, they cannot make it longer than the length of the trucks, right? Or the transportation equipment. So they
8 lanes, which is a pretty good size.
Yeah. So that's the largest one. Yeah.
Thank you. Okay. Well, that was very informative. Thank you guys very much. It was a great presentation. Okay, so what we'll do is we are going to, boys and men. So we'll take a 10-minute and then we'll come back and we'll get started with discussing the 3D. Okay, so we'll see you guys back in 10 minutes. So thank you again for the group 7. Let's take our break. Thank you. Okay, everybody. Is everybody back? Okay, so I just want to go over marking one more time just to remind everybody. So when you guys are looking at your grades for your presentation, right? You're looking at it, there's two parts to it. There's an individual part and then there's the group part. The group part, once you get it, that's it. That's not going to change. But the individual part can change and will change depending on how much participation you've been involved in. You know, you guys coming to the presentations, all these things, asking questions, that kind of stuff will affect it. Okay, so I give full marks at the beginning, but then by the end of the semester, those marks will change depending on how much you were involved. Okay, I know every time somebody asks a question, I note it down. So I know exactly who's been asking, I know exactly who's been here, and so on. Okay, so just want to remind everybody, because in case that changes, I don't want to get a whole bunch of emails saying, why did my mark change? You guys can look through the rubric and see that the group mark will not change at all. It will be your individual mark. Is that clear? Well, it can go up. It cannot go up because I gave you full marks for that individual mark right now. So it can go up. So either we'll stay the same or it'll go down. So depending on how much participation you've done, you can either keep it the same or go a bit down, right? So I made sure to, I didn't want to give everybody a 0 at the beginning and then C. I gave everybody full marks to know what your mark is based on, you know, if you would have participated every time, if you would have been here every time, things on, and then knowing what your true mark is if you decide to ignore that part of the of your mark. Okay, so okay, I mentioned this before, no problem. I mentioned this before and I'm mentioning it again, just for everybody to know, and hopefully people who are not here and are, you know, listening to the recording will know about this part. Okay, all right. So that's for the presentation. So we have one more presentation. So very excited, last one. And yeah, so I'm excited. It's next week, and then we're all done with presentations. And then the time after that will all be for you guys to work on your 3D project. Okay, so from after next class, it's going to be just work periods. Okay, all then after from, you know, really Tuesdays are really work periods, and so will Thursdays be as well, starting after week next week. All right, so for project, so let's go through the 3D project. All right, so project 2, you guys should be able to view this. It's online, okay, under assignments. I had not created a submission folder yet because I don't think most of you are complete. I've completed project 2. So what you're going to need to do is you're going to need to take certain parts of project 1. You're going to need to reference them into your project, into your C file, the one that is available for you online, okay? And it's under project 2. Okay, you're going to find your C file and you're going to find this document. So once you open up your C file, you're going to save it in the same way that you had saved the previous file. Now, before, a lot of people, okay, submitted this file, saving it as project 1. Next time someone saves it as project 1, I'm not going to mark it, okay? There is a convention of how you should save it, and it was provided to you in project 1 of how you should save it, that your name should be part of it, that you need to include all these so that when I mark it, I download all these and then I mark them. This makes it more difficult because then I have to check certain things, and then I have to make sure that I'm following through with the one that's lining up with. I understand your names. For some of you who did not even complete the title block, I can't even tell, right? But the rest, I understand you have it on the title block, but it should be in part of you, following instructions is following all the instructions, including how you name your project. So please make sure you name it correctly, okay? And you upload it with a DGM file. I am not looking for PDFs. And you should also be drawing your drawing in model space like we did, and then you're going to be presenting it in layout space. Now for project 2, you're not going to give it to me in layout space. You're just giving me the model, right? So that kind of gives it one less thing to do. You don't have to give it to me in a 2, you don't have to create 2D from a 3D, okay? So anybody, I just want to kind of make a comment out. Anyone who submitted a PDF, okay? There's a few that submitted PDFs only and did not give me their DGM file. Please contact me by email so that I can mark your project. I don't want to have to give anybody a 0. Okay, so please, 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 if you are one of them, please email me. Just to let me, I want to mark your project, okay? Okay, so that's for that one. So is everybody clear with the naming? So you guys have to make sure that you name it correctly. So download the seed file, name it from the beginning, so you don't have to worry about it later. Project 1 is not just a name. Everybody's project 1. Everyone has a project 1. But whose project 1 is it? It's yours. So for example, Hassan's, it should have Hassan Aziz's name in it. Okay? Mine would be Basan Al-Kadi, but everybody has their own name. Otherwise, I'm not going to mark it. You guys can take up just an extra minute to save it correctly. That's the first step. Project number 2. So you're going to download the C file. You're going to bring in, so you're going to reference in the bridge girder, the precast deck panels. Okay. You're going to reference in the parapet wall, right? You're going to reference in the asphalt, right? You guys already have that. So, and you know the thicknesses. So all these things you're going to have to reference in, all right? So once you reference those in, you're going to reference them in on the same sheet, on the same model. And then you're going to extrude them. Okay, so how would it look like at the end after it's been complete? I'll show you one. So this is the, oh, you can't see it. Hold on. So this would be the final product. Okay. I'm going to actually just make this bigger here. So this would be your final product. Okay. So we have here, these right here. These are your girders. Okay. And I'm just going to I can show this to you more in a, hold on, here we go. Here are your girders. Okay, so you can see it from the front view. All right, so you're gonna have to, bring those in for your girders. You're gonna have to bring in your parapet wall, okay? Your asphalt, you can see it here. All right, and then from there, you have to bring in your piers. Okay, so that would be looking at exercise, your exercise E. Okay, so that would be the pier. So you have the center one, and when you created it, then you'll be able to see here. You just need to extrude them. Okay. And of course, you have then your pads over here where you're just going to, again, extrude for the size. And then the girders sit on the pads and so on and so forth. So you have all the information that you need to place it. All you're going to do is really extrude it. Okay, it's going to take some time. So what you would do is you can go from one area to the next. Here I want to show you, like for example, here is the asphalt. Why isn't it working with me? Let me see, I have another one open. Can you guys see this one? This one has double, I don't know why. Anyhow, so why does this one have double? So all the parts that you have provided in your your precast panels, you would include under the asphalt. So you're going to take really project F or exercise F, right? And you're going to extrude it for the length, right? And how do we know the length? Remember, when we look, if you look at project or part, I'll tell you right now, project C, part C, that shows you the entire length, right? Because those sides here, those piers, right? And then the center pier here. So those ones are what kind of give you the length of it. And then you can have the parapet wall, right? And then of course the asphalt right on top, which you would have in exercise F. So exercise F is if you're cutting it this way, right? Taking a front view look, right? And then exercise C is looking at it from the top, right? If you don't have all the asphalt and the parapet wall, you're just looking at the piers, okay? And so on and so forth. So that's how you are going to start with the project. So I have some people who really start off looking at, the project C and to E, okay? And starting to, looking at here the piers and doing the extruding for this one, right? And doing each part. But remember, before you do any extruding, you have to make sure that they're a smart line. So if your stuff is not a smart line, it won't work. Okay, so all you need to do is join a line. Okay, so all you need to do is join it. So does everybody remember how to create complex? So you're going to create a complex shape. Okay, so let's say if I had, the heck? Okay, let me just, okay, so if I had a line, another line, another line, and so on and so forth, doesn't matter, I'm just drawing something just so I can remind you. If I want to make them into one smart line, I just create a complex chain. Okay, you can do it manual or automatic, either one. Okay, no gap. And then all I do is select 1, 2, and then it automatically selects the rest, and I just click outside. Once I click outside here and I click back in, you can see it already becomes a complex shape. It becomes one. Okay. You will need to extrude project F airfin, but the thing is, that's for one part, right? You don't have everything in that part. You don't have your middle pier here. So you're going to have to do that as well. You don't have to do every single one on its own, but you will have to, you can take F and extrude it, right? It has a lot of the parts, so it has all this part, the top parts here, but you'll need, for example, to do extra for the anything in the bottom, anything below. That's it. So yes and no. Okay. You're welcome. Okay, so anything else? Any other questions? So keep this in the picture in the back of your mind. Of course, it's recorded, so you'll be able to go back and see what the image would look like with regards to that. So, making sure you have that. And of course, the instructions kind of give you what information you need to kind of put together. So D and E, kind of look at the bottom, right? And then you have E and C, look at the bottom, and then you have your top as well. So you're gonna need to look at all those. Okay, and of course aligning them correctly, putting them on top of each other. Now that part, you're going to be looking at your project number 1, seeing how they would be, also looking at your drawing set, right? So knowing how that could be. Sorry, which you want the top view here? This one? There you are. You're welcome, John. Okay, so what is going to happen is from now on, every class is going to be a work period. You're going to come in and work. I'm going to automatically open up Teams so that you guys can communicate with me on a one-on-one. Of course, it's going to be open to everybody. I'm not going to do it like last time where it's one, I have to invite you in. It's like before where everybody just can come in and discuss. I find that that's the best way, especially now that you guys do have the tool for your 3D, because you have gone through the the certification. So you've done that. If you haven't, you should be, and that's going to be on you. I gave you guys ample time to finish that, and on top of it, you had your own time to do it as well. So if you haven't, I suggest you go ahead and do it. If you have, and you work away on this, and then if you have any questions, we'll discuss it on Teams. Okay, so from now on, except for of course Thursday's class where we'll have next Thursday's class, we're going to have a presentation at the beginning. It's really going to be work periods. All right. There's not much more that is going to be need to do more than what you've learned through the certification. All right, so go ahead and get started, please. Start working away, and then and now everybody remembers how to reference in correctly. Correct? Sorry. You guys remember how to reference in? No, you will not need any sheets, Arifin. No sheets at all. You just need to provide me this. So you're just giving me the GGM file with this. So only the 3D model, correct? Nothing extra. Okay? Okay, so as long as you guys remember how to reference in, we're all good. Okay, so get started. I'm going to open up our Teams. Okay, I'm going to stop recording. And